Key error, payment method, Thursday morning, 9:14, in production. This AI feature has worked perfectly for 6 weeks. Nobody changed its codes. Nobody touched its prompt. So what broke it? Another team plugged in. That's it. That's the whole crime. And by end of this video, you will exactly know why that's enough to take down a working AI feature, the one design idea that stops it, and exactly how to build that fix for real on AWS. Welcome back to AI architecture patterns. This is the pattern 02, the prompt and context contract. Last pattern, we build a payment support assistant that gives grounded answer. Today, a harder question. What happens when a second team start feeding that assistant data it was never built for? You just saw what happens. This video covers the design and the real AWS build in another video. I run the exact payload that crashed the dispute team assistant locally into the another recording. Quick orientation. For anyone landing on this one first time, I would request you to watch out for the first video of this pattern 01. One payment support assistant, not only limited to that. We are also covering another some different use cases also which can build using this pattern series. But we are locking ourselves to 16 pattern initially, one new idea each time. Two rules never change. We do homework, we do a lot of grounded validation of different things. Another one is to ensure that we run across similar terminology of what we're doing for the first pattern. Today, the pattern 02, the prompt and context contract, new idea, a written versioned promise about what a prompt needs from every caller. Do you have any new vocabulary there? If something new for you, I would request you to refer general theme about the generative AI in the Bedrock Quick Start, which covers a lot of things around this. Want to know about after this video or want to refer those content we have covered in the slide? Write-ups would be available on cloud2ailearn.dev. That's my side, and code will be on the GitHub. We'll have another uh, complimentary section for interview preparation question if someone asks you a question. One new word this pattern introduces, and a contract, a written down version and enforce. That's the whole idea. Now let's see why it matters. Quick recap before we start. Pattern 01 gives us the grounding. A payment assistant is only set to trust when every claim in its answer traces back to a real transaction or policy document. That's the pattern 01 in one line. And today we ask what happened when a second team start using the same assistant. Three stops in this video. Why? A second team plugs in a feature that worked for 6 weeks crashes. Nobody changed a line of code. What? What the fix? A contract, a version promise every caller gets checked against before anything renders. How? We build this for real on AWS. You see exactly where the managed service ends and our own code begins. Here is the world before the crash, which we are showing on the screen. The payment teams build this assistant. Their code sends four fields: transaction ID, payment method, status, and a policy. The prompt template expects exactly those four fields, and it works every single time for 6 weeks. Why? Because one team built that request ship, the prompt and the response together. Nothing could drift because there was nobody to drift from. Now, Thursday morning, the dispute team sees their assistant working great. They want it for dispute status too. Reasonably, yeah, right? So they wire in their idea. Their payload has two fields, and that's the problem. That's contain only transaction ID and status, not four. And here's the important part. They didn't do anything wrong. Nothing anywhere. Said payment method and policy hint were required. No schema, no dog, no error message. The requirement only existed as an assumption inside the prompt template. The payload sells straight into the render. The template asks for a payment method, and boom, we got a key error. To stick frames deep doesn't say which team sent it, doesn't say which field was missing. Support sees a 500. The dispute sees something went wrong on the screen. Root cause, it's not a code bug, a contract problem. The template assumes fields nobody ever wrote down. Quick picture. I don't want this living in your head as just words. This is the pattern 01 actual pipeline. Guardrail, DB lookup, policy search, and generate. Three steps deemed on the left already run. Not today's problem. One box lights up. Generate. Building a prompt straight from whatever in the request. Watch what happens when two different callers hit the same box. No contract key error. Two stake frames deep. Same as just we walked through later on. With pattern 02's contract in front of it, a clean named violation model never even called. Same box, same line of code. Only thing that changed whether something checked the shape first. Same broken payload, but now this pattern is in place. Pattern 02. Before the template, before any model call. One function runs, validate input. It checks the payload against the contract. Instead of a crash, the dispute team gets a structured response. Type, contract violation, and information about the missing field like payment method or something around that. By name, no model call, no crash. The dispute team knows exactly what to fix. The moment they send the wrong shape, not hour later from mistake text, it would be within a second. So that's the whole pattern in 3 words. Validate what it is all about. Check the caller's field at the team boundary before anything renders or call to the model. Version. When the contract needs to be changed, you create a new immutable version. In our case, the example of a dispute team, which is sending us just a two field status and the payment type. Whereas earlier we had a policy and the payment method as well. Never edit the old one in place. What is the render is? The template only ever sees input that has already passed the gate. Validate version render. Strip away everything. Here is the actual step. Caller sends a payload. Validate checks every required field, type and a contract version before anything else happens. Only then does the template render. Only then does the model get called. Nothing is skipped the first gate. That's the whole idea in one picture. Next slides, it's two real steps that simplify versions lived out. So the box counts about to grow. Same flow, now in full. The local architecture we actually built runs entirely on your machine or my machine. No AWS account, free 5-stage lab to write. One valid input fields present, write types, version known, hard get. Two renders. Placeholder filled with data that's already validated. Number three is the model call. Locally, that's a mock on purpose, but in real AWS or any other vendor, you are be calling their own APIs. Four, a step that's picture skipped, validate output. The the contract promise the answer shapes too. The five is the structure response. The model is never called until the gate passes. A bad payload never touches the template, right? Okay, so how exactly we will implement this out? Considering the different team, dispute team, and a payment support team has a different prompt required. One team is sending more data, another team is just sending two data. So the way it works is we'll do the versioning. So V1 is logged only for one team. V2 is logged for another payload, which is for dispute reference and dispute team. Now, the similar kind of thing, but it's a quick picture. Same container chain as the local version, just to showcase you that how exactly it works in real life. Assistant API is just API gateway lambda. Contract engine, Bedrock prompt client, same boxes, same jobs, identical code, all the way to here. The one box which will be swapped between locally is the mock response versus the actual API call response. Here is what we are showing in terms of what is shape. So Bedrock prompt management. There is the API log create prompt version. Create prompt is allowed by the AWS, which you can directly hook in. Okay, so now just to showcase that the production architecture, how you're going to build it in for real. And any team hits the API gateway, just assume that the caller hit the API gateway as the front road. That invokes Lambda. First thing Lambda does is validate input. That's what we're showing here. Same contract check you just saw. Notice the label your code. Hold that thought. Once the gate passes, Lambda calls Bedrock converts API. The API responded. Here is the elegant part. The model ID it passes isn't model ID at all. It's the ARN, Amazon Resource Name, which is the full form of ARN. Afterward, it make a calls to DynamoDB. Just a quick honest aside, you might be thinking that why should I need to create a new version or new Lambda every time or new API gateway for another team? If that is the case, that are we going to create a new infrastructure for every new requirement? So today is it was payment support on day one, day two was the dispute team. Tomorrow, let's say your fraud team comes up or they ask that, can I use it? So that's the option one where you want to keep the segregation in terms of how to build it. That can be taken, but it will be infrastructure would be quite heavy. Option B, one Lambda, but having a multiple versions and aliases with a one API gateway, and which is logically makes sense, right? Until unless you are dealing with so many requests or teams. Okay, this is the most important site in this video. I checked it against the real Bedrock prompt management docs before building anything because I got it wrong in once in the first place where in the variable where we actually pass the in the prompt I put out a single bracket quotes, but when I validate it's a double bracket quotes we need to pass it out, right? And the Bedrock also gives us immutable version number. It has an API provided audit trail, everything, right? What Bedrock doesn't do is it doesn't check your payload, what kind of field is present, what field type it is. That's not there, right? And the validation of those kind of things is via code or your logic. Now, this is more around how you exactly manage the different versions of Lambda if you're going with this problem. If we do, and if there are any issue, you can always roll back to the previous version. Honest disclosure before we move to cost. What we build is two of six real ways to enforce a contract on AWS. Picking two doesn't mean the other four are worse. Just one out of the scope for a learning and a build point of view. But I just want to give you the picture. There's a pediatric or instructor API support with the Bedrock is provided there. I would request you to refer those video link which is provided here. You can go to those documentation. AWS API Gateway Request Validator also can be used. That can also provide you some kind of a validation. Then you have other mechanism which ensure that you can scale on a larger point. Like you can create a flow, you can have a schema registry which ensure that you're following the right contract. And then Bedrock also has own guardrail which ensure the safety of outcome you're generating, and even the input schema can also be validated using guardrail. I would request you to go through those documentation to see about those. Right now, let's go to the next slide. Okay, so what does this cost? So locally, it doesn't cost anything. I'll showcase in the GitHub repo. You can go and check it out. On AWS also, that's a good part, right? Bedrock prompt management is free of cost. You can create how much you want it. You can check, and I have checked it with the AWS documentation. One more thing before we close the AWS build or today's video. What genuinely different between this demo and the production? Four things, right? Specific to this pattern, observability. CloudWatch proves the flow run, but you want a real metric. Contract violation per caller. A rising count is your early warning a team's integration is drifting before it becomes a support ticket. The demo's Lambda role in broad on purpose, so it reads on camera. Production scope to exactly the two bedrock action this pattern presents. So just to ensure that we are not only limiting ourselves to the payment support, and just to get in a broader idea where exactly this can help. So I think one of my colleague hit this exit bug at the logistic company. So um, the partner started sending order shipped event with a field name differently than the warehouse system always use. Nothing crashed. It just silently stopped matching order to shipment for about a day. Before anyone noticed, the numbers didn't add up. Same root cause as the dispute team's key error. Two system, one shared contact, no version. Domain change, healthcare intake. You can have a you can apply the similar kind of approach in the fraud, HR areas, right? And then you can apply the identity things on other areas also, which is I've just shown on the site. The number that convinced me this pattern was worth building, right? Stripe has run this exact versioning idea since 2011. 15 years. Every API version they ever shipped still works today. New caller get the newest version, all integration stay pinned to whichever version they started on forever if they want. That's not a best practice. That's the company betting their entire developer trust on never breaking old code. Tivolos is another example. Does the same for event tracking. A JSON schema tracking plan will hit every event versioning. Let's test those schema versions. I couldn't find a published customer story for Bedrock's own prompt versioning feature yet. It might be there, but it's too early to say about that. Last thing before we move on. This isn't a pattern to reach for everywhere. I actually almost added a contract to pattern 01 assistant before there was ever a second caller. So that's over engineering because if there's only one team who's going to use the prompt, there's no point of to introducing the additional latency on the flow. And the second is, and a contract is pure overhead, and it does the second caller shows up not before a contract checks up that as well, right? Also, the other point is that the question is whether the answer itself is good or not. So we can't validate via this pattern. So this pattern is more about to validate the contract of input. One more thing before we move to the next pattern series might be we'll record the some of the hands-on local demo also once we reach to a certain point in time. But these are the sources which I have referred during designing this video. And last but not the least thing, does this actually land whatever though is? So the one way to validate it to answer some of the scenario-based question which I have also crafted onto the site, which you can refer from my cloud to ailearn.dev. And the example I'm taking on the screen also where if your AI system is working fine for a payment team, but another team plugged in, then it creates the 500. I hope you will able to answer based on what we have gone today. Similarly, other questions also. I don't want to spend time on those one now. Okay, so one sentence. If you forgot everything else we talked so far, a contract, what you need to take away? A contract is a written, versioned promise about what a prompts need. Write it down, version it, never edit in place, right? And the example I took exactly for the dispute team, which I'll showcase into the demo. But if you really want to go from here, I would prefer you to go to cloudterra.dev, the full write-up and all 10 interview questions. Read the first, then github.com/my website or GitHub repo also you can check it out, right? And thank you.